see that if we're going to use our algebra, how would we consolidate these two? What would this be? So if I give you xy, let's do it this way. If I give you xy plus xy, what does that give you? 2xy. So if I give you 1 sine theta cosine theta plus 1 sine theta cosine theta, what do I get? 2 sine theta cosine of theta. And that is what sine of 2 theta is. And that's the one that you need to memorize. Easy to derive, easy to get, but when I give you a quiz over your identities, you're not going to have time to derive it. You just need to know it. Okay? So the same application happens here for the cosine of 2 theta. We know that that's the cosine of theta plus theta, which we remember from our little video that the cosines always stick together and the sines stick together, right? All right. So cosine times cosine is cosine squared. Sine times sine is sine squared. So we're going to go one of two ways now. We have two formulas that we can use, but you only have to memorize one because you can always get the other one from it. I know by my Pythagorean identity that the sine squared of theta plus the cosine squared of theta is equal to 1. Would you agree? So we can do a substitution. Instead of cosine squared, I can write 1 minus sine squared. Correct? Which then leaves me with 1 minus 2 sine squared theta. Right? Because a negative sine squared and a negative sine squared is a negative 2 sine squared. Correct? So there's one form of my double angle for the cosine of 2 theta. I can also then do a substitution for which one in my second option? Well, I did. Sine. So I can say, well then, let's say that cosine squared of theta minus, now sine squared we can write as 1 minus cosine squared of theta. And you need to be careful how you write that as you manipulate it. Some of you on your proofs are kind of getting your signs backward. You're telling me that sine squared is cosine squared minus 1, and so that's not correct. It's 1 minus cosine squared. All right, so this negative sign we have to pull through. And so I get cosine squared of theta minus 1 minus 2 cosine squared of theta. Sorry, there's no 2 here, is there? It's just, what should it be here? Plus cosine squared of theta. Well, now there will be a 2, won't there? Because how many of them are there? There's 2 of them. 2 cosine squared of theta minus 1. So there's the other one for the cosine of 2 theta. So it's either this one or this one. You can memorize them both, or you can just memorize one of them. As long as you have one of them, you should be fine when you're dealing with the cosine of 2 theta. Does that make sense? Huh? No, this is a development of your 2 identities. Given the cosine of 2 theta, I can either say that it's 1 minus sine squared, 2 sine squared, or I can say that it's 2 cosine squared minus theta. I've got 2 options when I'm wanting to use the cosine of 2 theta. Yeah, you can tell me that this is equal to this, or this is equal to that. Well, I'm deriving my identities, Jade. I'm saying that this is an application of my sum formula, correct? Which gives me this. And from this, I can either finish up and get this or this as my answer. I don't need to know the middle step, unless as an extra credit, I would ask you to derive it. Okay? Anything else here? No. Okay, so the tangent of 2 theta. Well, that's the tangent of theta plus theta. So let's derive it. When we use our summation for our tangent, we say that's the tangent of theta plus the tangent of theta, right? We add the first one and the second one over 1 minus, and what do we do now? We multiply them. Tangent of theta times tangent of theta. But what is this going to simplify down to? Tangent squared theta. And what is this going to combine to? To tangent of theta. Is that making sense? So here's our third one that we're going to want to memorize. This is what the tangent of 2 theta is equal to. Okay? Okay. So the sine of theta is 3/4. So we want to figure out what the sine of 2 theta is. So let's start by writing our formula. What's our formula for the sine of 2 theta? Two sine theta cosine of theta. Well, I already know what the sine of theta is. It's 3/4, correct? So what I'm missing is what the cosine of theta is. But we know that it's in the first quadrant. So we can draw our little triangle, can't we? And so we know that if this is my triangle in the first quadrant, and the sine of my angle is 3/4, then using our Pythagorean theorem, and be careful because this was a mistake on the quiz. Your Pythagorean theorem is always equal to the hypotenuse squared. So 3 squared plus x squared is equal to 4 squared is the way you set this up. And so what I have is that x squared is equal to 16 minus 9, which is 7. So this is √7 as our missing value. We derived it up here. Okay. So we're looking at our notes. All right, so that means this is going to be twice the sine of theta, which is, and now the cosine of that same triangle is square roots of 7/4. So this is 6 square roots of 7/16, which when we reduce it down is going to be 3 square roots of 7/8. That's what sine of 2 theta would be. Okay? Y'all following that? So what's my formula for cosine of 2 theta? I could use one of two, can't I? I could use what? Or isn't it 2 cosine squared theta? Minus 1. Well, which one would I probably want to use? Because, well, if I was given this, I probably want to use that one. But you could go either way, Emma, because in this case we also found what the cosine was, right? So 1 minus 2 times what's my sine of? So what am I going to do with this 3/4? Because I'm going to square it, right? I got to square it. So I'm going to say that's 1/1 minus 2/1 times 9/16. Yes? I'm just doing some basic math here. Are you following this? And so that's going to be, I'm going to take that 2 into the 16 8 times. And so that's 1/1 minus 9/8. And what is that as an answer? I hope you can do this in your head. -1/8. Because it's 8/8 minus 9/8. Are we good? So now let's apply the tangent to that same problem. The tangent is, what's my formula? Because 2/1 times 9/16 reduces to 9/8. Emma? Sure would. Yeah, that's why it really doesn't make any difference which route you take. It really is kind of dependent, Emma, on what's given to you. I mean, I could have gone the cosine route, but knowing that I was given the sine, I would have wanted to go the sines route. All right, so the tangent of 2 theta is what? 2 tangent theta over 1 minus tan squared theta. Okay, so we have not figured out the tangent of theta, have we? In this triangle? What is the tangent of theta? 3 over square roots of 7. And you know what? Let's just leave it like that for right now. Okay, don't worry about rationalizing it. Okay, let's just insert it in the appropriate spot. So that's 2 times 3 over root 7. And this is 1 minus, in my head, can I go ahead and square 3 root 7 and what would I get? 9 sevenths. Are we okay with that? Oops. This blue. Come on. It's like I can't even touch this. Okay, so my denominator, this is going to be 6 over root 7. And this is going to be, what is this going to simplify down to? Do it in your head? Negative 2 sevenths. That's right. So if you go back and look at what we derived, we said that the tangent of 2 theta is twice tangent of theta over 1 minus tangent squared. If I'm given tangent of 2 theta, this is the formula I must use. This? This? Well, but this doesn't help me. Tangent of theta plus theta, I have to use my summation identity, which gives me this. So this is the formula that I have to use. This is equal to this. This is the formula that I want you to memorize. And that's the one I want you to use. I will at the end. I will. I'm not done yet. So this is 6 over root 7 times what? 7 over negative 2, because I flip and multiply by my fraction, correct? Yes? Okay. So this is going to be, I'm going to take this 2 into this 6, and I'm going to get 3. So what I have now is negative 21 over root 7. Why is it negative? Because of this negative sign in front of my 2, correct? Now let's rationalize it. So that's going to be negative 21 root 7 over, which really is just going to be 3 root 7. Let's write it as negative. Make that clear. Did you follow the math? Yes, Sienna.
So when you were talking, like I did it by myself, and I just did in the fraction form, I rationalized the 7 and then
Fine.
crossed them out to that.
Absolutely works, yeah. I mean, there's more than one route. I chose not to rationalize till the end. Did you get the same answer?
Yeah.
So, all right, sine of 4 theta. Ooh, that's tricky. Okay? So sine of 4 theta, we want to think of this as the sine of twice 2 theta. That's how we want to approach this problem. Okay? Because we're wanting to use our double angle formula. All right. Well, that's going to be that's going to be twice the sine of 2 theta. Well, that's twice. What's the sine of 2 theta? Sine. Hold on. I did this wrong. I don't want to. So this is, okay, hold on. Let me think how I did this. So this is going to be 2, this is, I have 2 sine 2 theta cosine 2 theta. Let me think about this one. So I'm going to have 2 sine of 2 theta cosine of 2 theta. Does that make sense? Because we've got 2 of them going on here, right? Because I got this is this one right here, and I got 2 of them going on. Remember, The sine of 2 theta is twice the sine of theta cosine of theta, right, Danielle? But I have, instead of theta, what do I have now? I have 2 theta. So this is my 2 here. And I do cosine of my angle, sine of my angle. You following that? It's confusing, and you're. Yes, right. Because of my 2, this is my general formula, right? But what is my theta? Is 2 theta. Yes. Okay? This is a hard one. You've got one of these also in your homework. Okay? See, because this is twice theta. This is, Danielle, twice theta. So that's what I'm putting in here. But now I have twice 2 theta. So that's the value that's got to go in here. You got it? Emma? Then I would just done 4 sine of theta. Okay, but I'm doing twice my 2 theta. Okay? All right. So now we need to figure this out because we really need to know what the sine of 2 theta is and the cosine of 2 theta is, don't we? So we're going to, well, this is like a problem inside a problem. All right. So let's figure out that the sine of 2 theta, so this part is going to be this, correct? And what is the, what values are we using? Sine of theta is what? And the cosine of theta is? What is it? Where's my problem? Root 7 over 4. So this is going to be 6 root 7 over 16, which is 3 root 7 over 8. Right? So look, now I'm doing this part. I got to work inside and figure out what sine of 2 theta is. And the sine of 2 theta is 3 root 7 over 8. We do. Right. Okay, I can't figure out what the sine of a double angle is. I have to use my formula. So now I broke up my 4 theta into something that I can work with because I know what my double angles are. Okay, so I'm applying. So the sine of twice my angle is twice the sine of that angle, the cosine of that angle. But unfortunately, my angle is still a double angle. So now I need to figure out what the sine of 2 theta is here and what the cosine of 2 theta is here. Are you with me? Okay. And so we know that the cosine of 2 theta, we did figure it up from up there. We knew that it was what? This was negative 1/8 from above. Right? Right here. Are you with me? Okay. So now what am I going to do? I'm going to do twice. Now, instead of sine of 2 theta, what am I going to write? And instead of cosine of 2 theta, what am I going to write? Hold on, I guess this is 7. Do you see how I'm doing a substitution on this now? Joan, is this making sense? Okay. All right. And so this 2 is over 1. Would you agree? And it either goes into this 8 or to this 8, but it does not go into both denominators, correct? Because we're multiplying. We're not adding, so we're not distributing that 2. So we're just reducing. I'm going to just make this a 4. So this is going to be negative 3 root 7 over what? 32. Numerator times numerator times numerator over denominator times denominator times denominator. I don't, because if I gave you this problem, if I gave you 1/3 times 3/8 times 1/9, are you taking the 3 into both of these denominators? No. Okay, so I'm applying that same basic principle. All right, so do you want me to go through this one again, or does that make sense to you? Mirror it again, or are you okay? Okay, all right. And so that's why I had to think about this for a second, because I know that this is a hard problem. All right? All right, so let's try cosine of 4 theta. We want to rewrite that as the cosine of twice what? 2 theta, because 2 times 2 theta is 4 theta, right? Are you with me? So what is the cosine of 2 theta? Your general formula for the cosine of 2 theta is what? 2 cosine of theta minus 1, or 1 minus 2 sine squared theta. No, just sine theta, right? Okay, so that means now instead of theta, what am I going to put in here? 2 theta. So I'm going to say, if we use this one, that this is really twice the cosine of what? 2 theta minus 1. Oh, thanks. Okay. Hmm? You can use either one, but I just chose to go the cosine route. I don't know, because that's where I'm most comfortable with. But what is the cosine of 2 theta? What did we say that that was in the previous problem? Negative 1/8, right? Let me think. Hold on. Cosine of 2 theta. Let me think here for a second. I think this one's going to be different. Let me think. Let me think about this one, because I did this a different way. Cosine. Right. Negative 1/8. What, minus 1. But we got to square it. Right? Don't we have to square it? We're going to have to square this one, aren't we? Because we have the cosine of 2 theta is negative 1/8. But I got to square that. Right? So that's going to be 2 times negative 1/8 squared minus 1. We figured out what the cosine of 2 theta was, right? But I need to square it, don't I? Danielle? Are you following this? No? Okay. Cosine of 2 theta is twice the cosine squared of theta. So if theta was 1/3, we'd square it. I multiply it by 2 and subtract 1. This is our original identity. Either this one or this one. So we're going this route. Okay? So the cosine of twice 2 theta is twice the cosine of 2 theta squared minus 1. Uh-huh. Well, didn't we figure out what the cosine of 2 theta was in the previous problem? It was just negative 1/8, right? Here? Because this is my angle and this is a value. So I need to know what the cosine of 2 theta is. The cosine of 2 theta we did figure out as negative 1/8. Now what am I supposed to do with that value? Square it. So that's why I'm squaring negative 1/8. Okay. No, we didn't. Cosine of 2 theta. What is the answer to the cosine of 2 theta? It is simply negative 1/8. The cosine of 2 theta is negative 1/8. Cosine of 2 theta. It's only the cosine of 2 theta. Squared of 2 theta. No, this was because of this problem. So this is negative 63 over 8. And I'm done. Because it's going to be negative 63 over 64, and the 2 goes into 64, not 8 times. That's not right. How about 32? Okay? Well, how did I go from 64 to 32? Does that make sense? Whew. Okay? Got through that? Okay, let's move on. Half angles are easy. You don't have to memorize these. You can use these on a note card. These you don't need for next year. Now, tangent, this is what the book gives me, but I did a little more research. I don't like this one at all. We're not going to use that one. That's not a good one. It is annoying, and I can't ever get the right answer when I did this one. So here's what we're going to use. The tangent of theta over 2, we're going to say is going to be 1 minus the cosine of theta over the sine of theta. Isn't that prettier? That's the one that we're going to use. Wikipedia is wonderful. I'm like, really? I've never seen this formula before in my life. No, the other two are consistent. Sorry. Okay. All right. So these ones we're just going to use. You can have them on, or I'll just give them to you on the test. Okay. All right. So here we go. Use half angle identities to find the exact value of each trig function. Okay. So what's nice is if I want the cosine of theta over 8, I'm going to look at the cosine of theta over 8 divided by 2. I'm sorry, theta, that's not right. I want pi over 4, don't I? Pi over 4 all over 2. Because isn't that what theta over 8 is? I mean, pi over 8. Work backwards. What am I going to divide by 2 to get pi over 8? I'm going to let my unknown be pi over 4. That's how we get it. Because I know what pi over 4 is. It's a 45-degree angle, isn't it? Does that make sense? Okay. So what we're going to do now, where's my formula? Is if I'm doing the cosine, then it's going to be, this is my theta now. I've changed it and I'm using pi over 4. It's going to be, the cosine is equal to plus and minus the square root of 1 plus the cosine of pi over 4 divided by 2. I'm just applying the formula. Well, that's plus and minus the square root of 1 plus root 2 over 2, right? Over 2. Notice that 2 is in the denominator and under the root. Are you with me? Marielle? All right. So this is going to be 2 plus root 2 over 2. That's the numerator, all over 2. What's going to cancel out? My denominators are going to cancel out, right? So I multiplied this by 2 over 2 so that I could add my fractions. So isn't 1 2/2? And 2/2 plus root 2 over 2 is this stuff. And then these are going to cancel. And so this is plus and minus. And yes, you're going to get double roots. 2 plus root 2. And just leave it at that. You don't have to do anything with it to simplify it any further. No, it is. It is. Go back and look at your formula. Yes, you can. It's a mess. Okay? Yes? It's not a negative angle. My angle is pi over 4. But we're going to, and in this case, it should be positive because it's in pi over 4 is in the first quadrant. So this plus or minus will be dependent upon what quadrant we're in. So we will make this one just positive. All right, so the tangent of 15. So think about it. What over 2 gives me 15? Oh, come on, guys. 30. So I'm going to rewrite this as the tangent of 30 over 2. I'm rewriting it as a half angle. And so we're going to use one of we're going to use this one. We're going to say that the tangent of a half angle is 1 minus the cosine of that angle over the sine of that angle. Notice there's no plus or minus. So what's the cosine of an angle of 30? Square root of 3 over 2. Boo hiss for whoever said 1/2. What's the sine of 30? That's the 1/2. Okay, so that's 2 minus root 3 over 2 all over 1/2. You don't understand how I got a common denominator? Well, there's no root with this one. 1 is 2 over 2, right, Jade? I'm just getting a common denominator for my numerator. So 2 minus root 3 over 2 times 2 over 1 gives me 2 minus root 3. Oh, you know what? Is this right? I think I made a math error on this one. Does this 2 and 2 cancel? So this should be all over, this doesn't cancel, this is over 4. Because aren't they going to multiply out? Right? What's the square root of 4? This is 2 plus root 2 over what? 2. That's what this one becomes. I made a math error. And nobody caught it. This is 2 plus root 2. This is 2, so multiply it by 1/2. Right? That's going to be 2 plus root 2 over 4 all over 1. Not getting it? Because what's the square root of 4? Welcome to, this is the pre-calc part. This is the pre-calc part. And this is what you're doing next year. You're working with these all next year. This is why you have to know this stuff. All right, couple of verifications. Okay. But you'll get it better as you learn these formulas. All right, but you have to learn them. Cosine of 2 theta. Cosine of 2 theta. How do we write the cosine of 2 theta? So look what I have down here. What do I have down here? So I would probably want to use a sine one. I'm going to say that's 1 minus 2 sine squared of theta over 1 plus sine squared of 2 theta. But what can I, oh, it's not squared. How can I rewrite the sine of 2 theta? 2 sine theta cosine theta. I'm just rewriting these so I don't have any funky double angles or half angles going on. Okay? Now, leave it there at that point, and let's look at the right side. What? Okay? All right. So, what do I always say whenever I see my reciprocal functions? So this is cosine theta over sine theta minus 1. This is cosine theta over sine theta plus 1. Do my cosine thetas over sine thetas drop out? No, I can't just take it out of one term, and the ones don't cancel out, which was an error that I also saw. All right, so what we're going to do here then is we're going to say this is the cosine of theta minus the sine of theta over what? If I'm just working with the numerator. If I'm just getting a common denominator over here, cosine minus sine over sine, because I'm multiplying this one by sine over sine. Okay, what is my big denominator down here going to be? Cosine theta. I'm getting a common denominator up here, Danielle. And this is going to be over what? Now, what's going to cancel in this case? Okay, so what I really have is cosine theta minus sine theta over cosine theta plus sine theta. All right. Well, let's figure it out. You know what? Let's stop and let's go over some homework. And let's just continue on with this on Monday. Because I'm afraid that we'll finish this up.